3I/Atlas quickly captured the attention of the global scientific community and space enthusiasts for an extremely rare reason. It was confirmed as the third known object to originate outside the confines of our solar system. Its presence here is a vivid reminder that interstellar visitors, while difficult to detect, do occur more frequently than previously thought, bringing with them bits of cosmic raw material from distant regions of the galaxy. Our telescopes, with their increasing sophistication, are finally able to capture these rare passages through the inner neighborhood where the blue planet is located. However, due to a critical and peculiar orbital dynamic, we are about to bid a temporary goodbye to 3I/Atlas. The object is rapidly moving toward a position where it will be visually engulfed by the intense glare of the sun, temporarily disappearing from our terrestrial field of view. This phenomenon is not uncommon for comets, but it is crucial to understand exactly why this singularly important interstellar messenger is about to become invisible to observers here on Earth. For a terrestrial observer, the visibility of any comet is determined by a complex balance involving its intrinsic brightness, but above all, its relative position to the Sun and Earth. Even the most active comets can suddenly disappear from our skies. The main culprit behind this phenomenon is what we call solar conjunction. This is the moment when the comet approaches the Sun at an angular angle, getting so close in our line of sight that the intense and overwhelming sunlight completely obscures the object. The brightness of our star becomes an insurmountable veil, making it impossible to distinguish it with the naked eye or even with most telescopes. This is exactly the same reason we cannot see stars during the day, even though they remain there. When 3I/Atlas enters this conjunction, passing behind or dangerously close to the Sun from our perspective, it will cease to be observable, ushering in a period of frustrating visual silence for science, as it interrupts the continuous collection of essential data about its trajectory and composition. The situation becomes even more paradoxical due to the way comets behave. Comets exhibit their greatest activity, releasing the maximum amount of gas and dust to form their spectacular tails, precisely near perihelion, the closest point to the Sun in their orbital trajectory. At this point, ice sublimation is intense, and, in theory, the object should be incredibly bright. However, it is precisely at this moment of greatest brightness and activity that 3I/Atlas will be most difficult to see. From a terrestrial perspective, the object is very close, angularly, to the immense and blinding ball of light that is our Sun. In other words, the comet will reach its peak of material release, potentially displaying its tail in all its glory, but incredibly, it will be invisible to observers here on Earth, hidden behind the curtain of sunlight. Although Earth will experience this visual blackout, observation of 3I/Atlas will not be completely interrupted. Fortunately, there are space watchdogs, solar observation probes like SOHO Solar and Heliospheric Observatory and STEREO, which are positioned to monitor the solar corona. These instruments are built specifically to circumvent the problem of solar glare. They use complex occultation disks, called coronagraphs, which block the intense glare of the solar disk, allowing the corona and objects passing near it to become visible. While for us on Earth, 3I/Atlas disappears in a blinding light in space, these instruments can, in many situations, record the passage of these comets in detail. Thus, science is guaranteed vital, albeit indirect, monitoring during the occultation period, proving that Earth's disappearance does not mean the end of data collection. It's crucial to understand that a disappearance can have two radically different meanings. It could be merely a temporary occultation due to the comet's angular proximity to the Sun, with the comet then returning for new observations. But it could, tragically, mean total annihilation. Some comets, called sun grazers, make dangerously close dives to the star. These objects can disintegrate completely due to the extreme heat and intense gravitational tidal forces, never returning to our field of view. Comet Ison in 2013 serves as a historical reminder of this fate. It disappeared from Earth's view due to solar conjunction, and instead of reappearing intact, only fragments and dust remained. A close approach to the Sun can seal the fate of many objects. The disappearance of 3I/Atlas, while frustrating, requires careful monitoring to ensure it survives its critical passage. Fortunately, in the case of 3I/Atlas, all calculations indicate that its disappearance falls into the first category, a simple angular occultation. Its orbit is leading us into a period of visual silence, during which ground-based telescopes will be overwhelmed by solar glare, preventing direct observations for a few weeks. Currently, the comet still appears as a diffuse dot visible only with sensitive telescopes near the orbit of Mars. However, day by day, the apparent distance between 3I/Atlas and the Sun, in our line of sight, inexorably decreases. This loss of field of view will culminate in late October, coinciding exactly with the moment Atlas reaches perihelion. It is at this peak of activity that it will be completely hidden, missing the opportunity to record the potentially longest and most spectacular tails formed by the maximum sublimation of its material. Unlike grazing comets, 3I/Atlas offers a respite from the risk of disintegration. Its trajectory is relatively comfortable, with a perihelion point occurring at a safe distance of about 202 million kilometers from the Sun. This avoids the catastrophic fragmentation scenario caused by excessive heat and powerful solar gravity, ensuring the interstellar object's survival. However, the fact that we are not at risk of losing it permanently does not minimize the frustration of missing the peak of its gas and dust emission when its tail would be most spectacular. Even so, the scientific community will not be left empty-handed. Thanks to space platforms such as SOHO and Stereo, equipped to ignore the Sun's glare, it will be possible to indirectly track 3I/Atlas's silhouette and trajectory, providing continuous data that will fill the gap left by Earth's blindness. It is essential to reiterate the unique importance of 3I/Atlas. It is not just another periodic comet. It is an emissary that has crossed the abyss between the stars, carrying with it the chemical signature of distant regions of the Milky Way. Its much faster trajectory and its likely origin in the galaxy's thick disk make it an incredibly rare study piece. Every bit of observed data, whether on the composition of its nucleus, the structure of its coma, or the color of its tail, provides vital clues about the diversity of icy worlds wandering interstellar space. Such objects function as windows into the initial conditions of planetary formation in other systems. For this reason, the wait for its reappearance is anxious. The hidden period without direct observations is a hiatus in which we could be understanding the formation of ices and minerals outside our solar neighborhood. 3I/Atlas's triumphant return is scheduled for late November, when it will finally move angularly away from the Sun and emerge from the glare, becoming visible again to our telescopes, even at a colossal distance of 268 million kilometers from Earth. However, it is unlikely that it will return exactly as we saw it leave. During this hidden period, the comet is subject to intense interactions with the solar wind and radiation from near our star. Such interactions can drastically alter its appearance. The tail may elongate further, change orientation, or in more extreme cases, the nucleus may have undergone some fragmentation. The Sun not only hides it, but also acts as a powerful agent of change in its structure. When it reappears, it will open up an exciting new opportunity to collect data on its composition and structure. The disappearance is temporary, but its return promises an object transformed by its daring journey around the Sun, ready to reveal new secrets to us.